Welcome to our first of hopefully many video lessons on physical science out of the Abeka book. Right now we are on chapter 10 and we are talking about motion in this chapter. So we're going to start getting into some more physics-based things. So when you're talking motion, just like I said, you are talking physics. Physics is the study of motion, how things move and work, force and energy kind of just in the world, all right? And we break physics down into two categories. We break it into classic physics and modern physics, and it's divided right or roughly around the 1900s. So anything before the 1900s is classic physics. And those are some of the big names: Galileo, Newton, some of those bigger names back that you've probably heard of. And then moving forward from there into modern physics, more things dealing with a lot of pressure and forces, energy, even into lasers, things like that. With Boyle and Bernoulli and a lot of principles of flight, things moving a lot further forward. And so that's what we're going to be looking at. We're going to start moving into is physics. You're going to hear a lot of these names as we go on. There's going to be a lot of laws and rules that these people have created and hopefully have tested to the point where we can consider them true fact or a law in science. There are some theories out there that can't be necessarily tested, but physics, for the most part, will deal with laws and mathematical formulas for things in our universe, ways to explain things mathematically through science. Okay. All right. So our first few terms that we're going to look at, just to help us understand what we are talking about as we go through these next couple sections. First term is scalar or vector quantities. Okay. So scalar quantities and vector quantities are two different types of quantities. Okay. Scalar is based on just a magnitude. Okay, so a distance such as 20 feet. All right, that is a scalar quantity. It is a number. It doesn't tell you too much, right? If I told you there was a treasure buried 20 feet away from you, okay, you have a distance. You know something. All right, that is a scalar quantity. It's just a number, a size, a weight without any other direction. All right, a vector quantity, I'm assuming you've seen, maybe you haven't, Despicable Me. A vector is a line with both direction and magnitude, right? And so, probably comes off funny, not as funny on the video as it is in my head, but vector quantities are quantities with both direction and magnitude. So they have magnitude, 20 feet, but they also have some sort of direction tagged onto this. So this is 20 feet east. All right, if I told you the treasure was 20 feet due east, you could walk 20 feet that way and find your treasure, right? It would be a lot easier. It's a lot more information, and it's a lot more descriptive, okay? Next thing we're going to talk about with this is displacement, okay? And this is simply an object's change in position, okay? The idea is if you traveled, let's say you traveled 20 feet, okay? You started here and traveled 20 feet this direction, right? Your displacement would be 20 feet, okay? However, if you decided to walk back 5 feet towards your start, okay, and then you were now here, right, your displacement would be 15 feet. You went forward 20, back 5, and now you are 15 feet from your start. So displacement is your change in position, all right? So moving off displacement, a big thing is learning how to calculate that kind of change that happens in something like a displacement. And we're going to move into a term here called delta. All right, it is symbolized by the Greek letter delta. All right, it's a big triangle there, as you'll see that. And this symbol will be very, very important moving through almost any science that you take from here forward. Okay, you'll see this in physics. You'll see this in chemistry. You will probably see this in every science you take in the numbers field, right? Anything that deals with numbers, all right? What does delta mean? All it means is change, okay? So if something changes, that is a delta, all right? If the temperature goes from 50 degrees to 40 degrees, you have a delta T, which is a delta temperature or a change in temperature, okay? So delta is change. So when you are trying to calculate delta, when you're trying to figure out how much something changed, the number, the value of something changing, we use this equation right here, okay? It says delta x equals x final minus x initial. Okay, let's break that down. X is just a variable. All right, you can stick any word, any value you want in there, and you can find solve for that with this equation. So for our example, delta T, that would be change in temperature, right? We can plug that in. So delta T, and you just plug T in for everywhere X is. So T and T, right? So delta T, change in temperature, all right, is equal to the final temperature, what it is at the end, minus the initial temperature. So however much temperature you started with. For example, you walk into your house this afternoon. It's nice and winter right now. Maybe it's not when you're watching this. But let's say you walk into your house and it is 60 degrees inside. All right, it's 60 degrees when you walk in your house. We'll go Fahrenheit. We're in the United States, okay? And you turn on the heater, right? You decide it is too cold. I'm turning on some heat. All right, after about an hour, it is now 70 degrees. All right, it's about as hot as I ever want my house. I can't breathe after that. It's just terrible. All right, some of you guys like it 75, 80. I can't do that. I would be on fire. All right, but we went from 60 degrees to 70 degrees. All right, now I know these numbers. You may be able to do this in your head, but this equation works for any number, any crazy amount you want to use, and you just plug it in and get the answer. So we came into our house. Our initial temperature, our start, was 60 degrees, right? 60. All right. And our final temperature, after the air conditioner heated up the house, the heater technically, all right, was 70 degrees. So our final, our X final was 70. All right. 70 minus 60 gives us a change of 10 degrees. All right. So our change in temperature was 10. All right, we went up 10 degrees. All right, let's run this again. Like I said, you can calculate anything with this equation, any change that you want to calculate. So let's try that. Let's put that to the test. All right, so delta D, change in distance. Let's say that you were going somewhere. You want to know how far you went. All right, well, your start, wherever you start, let's say you start right here in this spot at the school. Your spot actually typically is 0. Because you have not moved anywhere. If you have not moved anywhere, your distance is 0. You're at point 0. You're at the start. Okay? And let's say you walk over to the lunchroom and you are trying to, eat lunch, whatever it may be, and you ended up 40 feet away. All right? I know these once again are pretty simple numbers. This section actually will be pretty simple numbers. Hopefully, there's no tricky math involved here. Okay? So your initial is 0. Your final would be 40, where you ended up. 40 minus 0, you went 40 feet. Okay. All right. So earlier we mentioned displacement, right, which is the change in position. Okay. Now this is different from total distance traveled, and I want to take a look at that real quick. So let's say this morning you woke up at your house, okay, and you drove 3 miles to school. Right. So you drove to school 3 miles. All right. And then you left school and you wanted to get some fast food. So you drove 4 miles, all right, over to the nearest fast food chain to get a burger. Okay. Now, once you are here at the fast food chain and sitting in the drive-thru, okay, how far are you from your house? Okay. Because everything's not in a straight line, right, you may not be the same distance away from your house as the distance you've traveled. So you traveled 3 miles up, 4 miles over, you would think, oh, okay, I've traveled 7 miles today, right? But in reality, you draw a straight line between your house and the fast food chain, and it's not 7 miles, okay? Typically, right, you have 3 points. That creates a triangle. And simply with triangles, we have a nice little equation. I'm assuming you have probably learned it at some point. It's the Pythagorean theorem, okay? A squared plus b squared equals c squared. If you need any help with that, please ask me. It is very easy to plug into your calculator. But what it says is the hypotenuse, all right, or this line right here, the longest, all right, across from your right angle, all right, the hypotenuse down here, all right. When you square that length, so c squared, it is equal to these other two sides squared. In our case, 3 miles and 4 miles, so 3 squared plus 4 squared, okay? And we add those together, I think we come out somewhere to 5 miles away from our home. All right. This is 16, this is 9, that's 25. Square root of 25 is 5 miles. All right. Does that make sense? Hopefully. If you have any questions, once again, feel free to ask me. I will be available in class all day. So let's look at another example. We're going to have some vectors up here. Once again, that is aligned with direction and magnitude, so distance and direction. All right. Let's say that your school, the fast food chain, and your house were all in a straight line. Okay, because sometimes you do move in straight lines. It is a possibility in our universe. All right. So let's say you traveled. All right. We'll start your house here. Let's say that in the morning, all right, you drove all the way to the fast food chain to get breakfast. All right, that was 10 miles. All right, and that is, we'll call that east. 10 miles east. All right, you moved 10 miles east all the way to get food. And then after you grabbed your food, you drove back to school, and that was 4 miles. Okay? And that was directly back west. All right, so you came back from the fast food chain to school 4 miles west. Okay? The nice thing, we just did the Pythagorean theorem. A squared plus b squared equals c squared for the triangle. When you're dealing with straight lines, your life gets a lot easier. It is simply addition and subtraction. Okay? So we're going to start with our initial direction and say that we traveled 10 miles. Right? When you do initial direction, there's not necessarily a positive or negative direction because there's no finish line, there's no ending. So whichever direction you traveled, we'll call that positive. School bell. All right. And then you traveled backwards, right? It's the opposite direction of your initial. All right. It's the opposite direction. You traveled back 4 miles. All right. So you traveled 10 forward, 4 back, 10 minus 4. You add them very simply. If they're all going the same direction, you would add them together. If they're going opposite of each other, you subtract. So you are 6 miles away from your house. All right, 6 miles, 10 minus 4, 6. All right, now let's say that we're talking and you didn't go to school. Let's say it was a weekend. You passed right by school. All right, you went to McDonald's, got some food, and then you went to the movie theater. I don't know what movie theaters really look like. They have one of those big signs out front like that, okay? All right, so you drove on to the movie theater, all right? Another 3 miles. All right, so you went 10 miles to the fast food place, and then 3 miles further to the movie theater on the weekend. All right, these are both in the same direction. They're both east. All right, and so you traveled 10, and then 3 more. You add those together. 10 plus 3, that's 13. All right. Does that make sense? Hopefully. If not, once again, feel free to ask me any questions you have. So, quick terminology here. All right. When we add 2 vectors together, right? You traveled from home to school 3 miles north, and you traveled from school to McDonald's 4 miles east. Okay. Whatever you're adding, when you add 2 vectors together, right? The third vector that you calculate, all right, either the Pythagorean theorem or if you're adding them, subtracting them, the final vector that you get out of that equation is called a resultant. Okay. When you add 2 vectors together, the third vector that you get is the resultant. All right.